is Sean Bergen. I'm a member of the CompasNet educational team. In this module, we'll discuss the importance of including metadata with your computational model code. Let's begin by defining metadata. Metadata are usually described as the data about your data, or in our case, it's the data that describes your model. It is the information that will let other researchers find your work, among possibly thousands of other entries, quickly judge its relevance within their own project, and cite it correctly. You are likely already familiar with some metadata fields from publications like journal articles or books. Software objects should be uploaded with a list of associated information too, just as the contents of journal articles or book chapters are tied to machine searchable data. Data that includes their title, an abstract, the date of publication, and keywords. Without metadata, databases wouldn't be useful because they wouldn't have any structure, and they wouldn't be searchable. Some of the metadata fields needed for software are analogous to the ones referred to by journal articles. You want to add the title or name of your model, a set of meaningful keywords, the name of authors, although that sometimes can be complicated with software, especially with GitHub contributors, the date of release, and very importantly, the associated persistent identifier, or DOI. Similar to providing an abstract for your article, it's also important to include a rich description that describes its purpose. Was it developed to calculate, predict, describe something? And the formalism it follows, whether it's machine learning, it is an agent-based model, for example. There are other metadata fields that are only meaningful for software outputs, but are critical for the purpose of making your work fair. It's important to include the model's version, the language or modeling platform used, including the version of this software too. Sometimes there are actually multiple languages within one particular model, and one must include software languages and the versions of those languages. Dependencies, any extensions or packages that are used, any additional software that's needed to run the model that you've created. In the case of models in R, for example, there might be specific packages that are needed to use your computational software, and each of those packages has specific versions that also must be included. The system requirements needed to successfully run the software. And finally, the license. All of this information should be human readable, but also machines should be able to use it to produce useful search results. And metadata standards help ensure the information is available for both. There are different standards, and the archive you choose may guide you through the creation of metadata for your software. Not every field needs to be completed, or can be completed in some cases, but the more information is provided, the easier it is for people and machines to categorize your work and display it when it is relevant. It can be confusing to think about metadata and documentations as descriptions of your model. What's the difference? One way of thinking about it is that metadata is the type of description that will let researchers find your work, while documentation is the type of description that will let them understand it. Let's finish this module by going through a minimal software metadata checklist. When publishing your model, you want to make sure you provide the name, the version, the language or the modeling platform that you're using, sometimes both, any important system requirements, a rich description, much more than an abstract, authors, the release date of your software, any sort of persistent identifier or DOI, and finally, its license. In the next module, we will discuss the importance of code management.